Thank you for the introduction, and it's great to be here. I'm Sveta, and I'm going to talk today about analyzing public conversations in social media using LDA model. So a little bit about myself. My name is Sveta. I'm one of the founders and the CDO of Memphis Dev. I'm a software engineer. I really love graph theory and networks, and when I see networks, it makes me excited. I play football in a mom's soccer team, football team, so I'm going to say football. If someone here from the United States, I apologize in advance. And I'm a Harry Potter fan. When I need to relax, I just read the book, and I'm still waiting for my letter from Hogwarts that didn't arrive yet. So, I'm going to talk today about analyzing public conversations. And as I told you before, I'm a newbie on football. I don't know anything about it. When men talk about football, I try to enter the conversation and I don't know anything. So I want to start to investigate, to know what are the topics that everyone's talking about football. So I want to know the highlights and try to investigate. So I'm going to show this architecture on the football domain. How I'm going to do it? I'm going to collect data from social networks. In this presentation, it's going to be from Twitter, but it can be from any other social media network. I'm going to analyze the collected data, and I'm going to visualize it with Tableau. So you probably ask yourself, why social media? And the simple answer is because everyone is there. I believe that any one of you is acting inside one or more social medias. And most of the world is there, almost 60%. In Europe, United States, it's more. This slide I took from the global social media statistics research. And not only that we are acting inside social media networks, we're in the networks that people talk inside. There's Facebook, where people write posts and act inside groups. We have the YouTube that people are talking, WhatsApp that we communicate, and more. So how I'm going to do it? I'm going to do it with social network analysis, which is called SNA, which basically takes the actors and put them inside a network. The nodes are people, the actors, and the relationships are the links between them. So, for example, in Twitter, I can make the connection, the edge as follow someone who's following, retweeted someone a few times, and that makes my edge weighted, and someone who liked the tweet. In Reddit, there is no connections. I can create my own artificial connections, which means if someone asks a question, so I can see if someone replied and create an artificial connection between them. Can someone offer me a relationship from LinkedIn? Oh, okay, so in LinkedIn, we have connections. So if we are friends on LinkedIn, it's undirected because we are together, it's mutual. Maybe I can follow someone, which will make my link, my edge directed. And it's a little bit a less powerful connection. Well, social network analysis tries to understand the communities inside the network that we build. If we have a network of people with connection and relationship between these people, we can try to analyze it and build communities. For example, we can see here some network with different colors. The colors means that every color is in a different community. There are a few ways to do it. The most common way to find a community is to try to isolate nodes, the people in the community, and try to search for pests. This way we can find communities and find people that share some common interests. I'm going to demonstrate it on the 6 degrees of Kevin Bacon. Someone's familiar with 6 degrees of Kevin Bacon? Well, for those who are not familiar with this is some kind of, we're showing with 6 degrees of Kevin Bacon the concept of 6 degrees of separation, which means that every 2 people on Earth have 6 degrees, 6 links to get to each other. For example, now we have a new relationship. We've been in the stackconf together, and we can just create another relationship, been in a conference together. So now, if I know someone that's been in some conference, for example, in Miami, so I have 2 degrees from a person that's been in the conference in Miami because someone that I know now met him. So back to Kevin Bacon. The graph is the network. The network is represented the graph. The actor Kevin Bacon is in the middle, okay? And the first person who acted with Kevin Bacon in the same movie has first 1 degree of Kevin Bacon. The nodes are the people, the actors. The links are the relationships. The relationship here is acted together in a Hollywood movie. If I take a subgraph, for example, the top one, I can find here a community that shares something together. How is it going to help us? So, as I told you before, I'm going to try to understand something about football. I'm going to build a community. I'm going to build a network of people who talk about football. It's going to be influencers, professional people, accounts in Twitter, in my case, that are talking and tweeting about football. Then I'm going to analyze the tweets that they tweeted and try to understand what they are talking about. Okay, so where to start? Okay, so just as someone who's coding for professional, I just did what everyone does when they don't know. I Googled. I just wrote, who are the top accounts that talk about football? And I received these 10 accounts. Then I started to build a network. Okay, so the goal account follows BBC Sport and Sky Sport News, which follows the next account. This is the beginning, the initiation of my network. Okay, now I want to expand my network. To expand the network, I need to build some ranking mechanism. I want to know if I'm seeing an account, to know if to put it inside my network or leave it outside the network. So I built so the mechanism that I built depends on the accounts that my accounts are following, because if BBC Sports follows some account, it's probably an important one. Using keywords, maybe BBC Sports following some account of, I don't know, maybe a football player that is influencer, but usually what he posts, it's only commercials of things that he's getting paid of. So I'm not sure I want to follow this one or someone famous else. So I just want to see that accounts that my initial network are following are accounts that using keywords that related to football. Next, I want to ensure that this account has many followers, which it means in our world that it's important. Okay, I'm not sure it's in the real world, it's like this, but in social media, if you have many followers, you're important. And accounts that have been retweeted by our network, accounts that are influencers don't retweet much, things that are not important, so I want to follow these accounts as well. So this is the pseudocode for the ranking mechanism. I just made something very, very simple. For example, if account is beneath the threshold for number of followers, I rank it as low. If account has many followers, but it's not followed from someone in our network, it's medium. And if this account doesn't uses keywords, it's high. And then I have to decide, I have to make some decision. If an account ranked high or low, it's okay. I can say that if account is high, I will automatically put it inside my network. And if it's low, I will release it and won't look for it again. But if it's medium, if it doesn't have too much followers, but uses keywords, or been retweeted, but it's not such a big account, Well, then I need to review it and decide myself. I can do it with thresholds, I can do it mechanically, but usually when we do it, we decide we take some person who's going to review this account and decide if it's in or out. So now we can see the expansion of the network. We begin with the 10 accounts, and every day we add more and more accounts. Well, this mechanism, when we build this mechanism, it's important for us to put some thresholds in order to determine how fast we want this network to expand, because sometimes when we use different domains that has many interests, there are many accounts that act inside this domain, and the network is exploding. Also, different networks are more professional, and different networks are less professional, so it depends on the domain that we want to find. So now that we have the accounts, I want to know what are they talking about. And now I'm going to do it. I'm going to show the architecture of how to analyze the public conversations for the list of the accounts that are already collected. So I start with the accounts. The accounts can be stored in the list. In my case, I'm going to show you the code that I stored it inside the text file. It can be inside of database. It can be the model that collects and ranks the influencers can be separated and just put it inside the database. So from that database, I collect the influencers. Then I collect the tweets from Twitter. And then I produce it to Memphis stations. Memphis is an event processing platform that can act here as the buffer between the between the tweets and to the analyzing functions. So basically, I use Memphis as a queue here, as a buffer. And why I produce it 3 times? Well, now I'm going to show you the analyze. The analyze is a batch processing. I wanted to make different periods of collecting, analyzing times. Since I'm working with Twitter, there is a rate limiting, and I took the basic plan. So the basic plan gives me amount of tweets that I can collect. Can I collect in 1 hour, for example, or in 1 day. So I run it in circles. Every 1 hour, I'm making a query and collecting the tweets. The analyzer part, we're going to run every 24 hours because I want to do, in long periods, a batch processing. So I store my tweets in 3 Memphis stations. The difference between them is the retention. Retention means after receiving the retention time, the message will be deleted from the station, from the queue. So the first one is with retention 1 day. This one is with 3-day retention, and this one with 1 week. And why? Because I want to analyze tweets on different periods of times. I can see what was the conversation about football in the last 1 day, in the last 3 days, or in the last week. And this kind of trying to make a sliding window. Now, the analyzer part. The analyzer part begins with the consumer. Each consumer consumes messages from the stations and runs a pre-processing function. The pre-processing function depends on the source. For example, since I'm working with Twitter, I want to remove RTs, I want to remove links, I want to remove emojis. In Facebook, there are different things to remove. Instagram are different things. Maybe I want to analyze the images inside and have a capture of the image. After I'm doing the pre-processing, I put it in another buffer. The other buffer is another Memphis stations with the pre-processed information. And why? I want to consume the data and run the LDA model. LDA is topic modeling. Okay? I want to decouple from the pre-processing from the LDA model. Why? Tomorrow, I will want to add LDA2 or another topic modeling function. Okay? This way, the pre-processing and the LDA model functions are decoupled and they not depend on each other. I can just plug and play and replace the function or add more functions. Also, Pre-processing function can run very quickly. I made it with regular expressions or texting functions. An LDA model can be a little bit slower. This way, I can control on the times when I want to run the different functions, and won't be delayed. Okay, and the last thing is LDA receives some unreadable output. Every topic that created from the LDA is a bunch of words with weights. I want to see how it looks. I want to do something with it. So I push the output to BigQuery that has a native connection to Tableau, and then I can visualize it and create metrics to analyze the things. Okay, so I'm going to show you a snip of the code. So as I mentioned before, I have an account. Okay, so I'm getting the accounts list. It can be from a file, from a database. In my implementation, I just took it from a file, connected to Memphis. Memphis, as I told you, is an event processing platform. It can be on you can use it in a cloud or as an open source and deploy it with Docker or Kubernetes. And then I took every account and I made a query that gets the tweets, which I implemented myself. I took the things that are important for me from the tweets and pushed it to the three different stations, as I mentioned before. So about the rate limit, I told you before, since we have different rate limits, I run my code every 1 hour in order not to get blocked from Twitter. And the deduplication, because it's queries, no one guarantees that I want to receive the same tweet twice, and I don't want to push it to Memphis. Memphis has a feature of idempotency, which means when I send in a message ID, if a message ID is already existing in a station, it won't be produced again. So I have every tweet has a unique number, which is tweet ID. So when I put a tweet ID inside the message ID, I guarantee that same tweet won't produce twice to the same station. Okay, so this is the station overview. You can see I took a snapshot of the stations a few days ago. The total messages are different. Why? Because of the retention. Every 24 hours of a message that exists inside the station is being deleted. And here after 3 days, and here after 1 week. Now it's larger. I'll show you after the presentation when I show the demo. And this is how it looks inside the station overview. So this one is 7 days retention. Here you can see all the messages that's stored inside my station. And even now, when I click on something, I can see there was something happened with the Spanish coach in the women's football team. I don't know if you're excited about women's football, but the Spanish team won the World Cup, so the female. So something happened there. I encourage you to check yourself, because it's a gossip. So now the analyzer part. As I told you, I put Memphis stations as a buffer, but since I want to show you a demo, I don't want to implement too many producer consumers because it repeats itself. So only for the slides and for the demo, I just put these functions one after the other without buffers. So I have 3 periods, 1 day, 3 days, and 7 days. I took this timestamp. I show you afterwards why. And I started to consume from the stations. After consuming, I'm creating the pre-processing, then the LDA model, and then I upload it to BigQuery. So this is my pipeline. We're here in the consumer. We are here in this part. So the consumer. The implementation of the consumer. So I connected to Memphis, and I just some simple ifs. If it's 1 day retention, period. So I go and take the messages from this station. If it's 3 days, from this one. If it's a week, from this one. I'm using the fetch to consume. And when I read all the messages, I just return a data frame with all the tweets from this specific station. Okay. Also, I have this. I have to ACK every message. Every message that acts from one consumer won't be sent again to this consumer. So that ensures me that each consumer gets only one time the same message. Now for the pre-processing part. So I have only tweets, but I showed you what I would do if I want to have only Twitter. Since this is Twitter, I made a pre-processing text that's for Twitter. This pre-processing removes the HTML tags, the HTML characters, the emojis that people have to send. I also added to the stop words the letters RT, which means retweet. I won't do it for other data source. And tokenize the data for tokens. Each text message was replaced with tokens. I saved it, applied it to a pre-processed text to my data frame. Okay, it's my first time with this, so. Okay, after pre-processing, I'm here in the model. I ran the topic modeling. Well, here I showed only the simple version. Just I created the dictionary I ran inside the LDA model with 5 topics and 10 words in each topic. Well, this is only the basic of the basic. I should play and check and understand in different domains what works for me what works better for me. For example, I can use 5 words for a topic. I can make only 3 topics for each domain, and also just to put the dictionary that I created, it's not enough. I can use 2 grams, n-grams, which means a collection of words that are one after each other, in order to analyze better the conversations. This model can be tuned and be a little more powerful. And after I finished the LDA model, I just push the output to a BigQuery. So I added these topics, which is the output of the model. And for each topic, I just put the topic itself. I added the period of days because I want to be able to filter in Tableau. And the timestamp, in order to ensure that each run of the LDA model will be presented in the same place, in the same dashboard. Okay, and now I have a screenshot of how it looks. So I removed the weights, and each topic it contains 10 words with weights. Weights won't give me anything now. So this one of the 10 accounts, with the 10 initial accounts, I received for the last 3 days from this station. It was a few days ago, so I don't know if it's something too new. For the last day and for the last week. Well, it won't give me anything. I can't understand this. But when I use my friend ChatGPT, I ask him to take these weights and these words and make me something more readable. So now it makes a little bit more sense. So I know that now that Manchester United renewed the English football team, and I can understand more easily what are they talking about. So after completing this process, I'm not a football expert, but I can go and check and to read and to understand what's going in the football domain. I know that something happened with the Spanish team, women team. I know that something is going with Manchester. I can start to investigate, and I know where to begin. Well, this is this was only the basic of the basic of the basic. I can improve it. I can produce the different partitions. When I have the station, just think about it as a queue. I can partition the station, and to make different partition to have different time period. Different sources. For example, in the same station of one day, I can put inside one partition data from Twitter, data from Instagram, data from other source. I can analyze the communities and put inside the different partitions different communities, which means different accounts that combined inside the community. I can collect from different sources. I can enforce schema to the stations. And why it's important? My LDA model gets raw data that pre-processed. The LDA model doesn't know what is the source. Different source brings different schemas. For example, I have text in Twitter, but I have maybe post in Facebook. And if I push it to the station, the downstream model can be broken. So I'm going to control it in the upstream, which means I'm going to enforce a schema on the station, which ensures that nothing in the continuance of the pipeline won't break. Another thing I can do is to use storage tiering. When reaching the retention in Memphis, the messages are deleted. We have a feature of storage tiering that pushes the messages inside S3 bucket, for example, another remote storage, which will enable me to connect to other solutions like Apache Iceberg, to Spark, and I will be able to do a batch processing that is more robust. I can consume from different stations, from different partitions. I can make my LDA model a little bit better, and maybe to run some practices, I can use other models. I can combine models together. And it's very easy, because I have these buffers, the stations, just consume, add another consumer, and push to another new function. And of course, I can use longer language models in order to understand and make it more readable, the output of the LDA model. Well, in the visualization part, I showed the words in Tableau. There weren't any metrics or nothing, so I can show the topics over time, how it's changing over time. I can create metrics, for example, to count words that appears more and maybe are more important in the topics. So I can also make the visualization much better and much understandable. And now I think I'll try to show the demo. So here's the overview of the stations that I'm collecting. I filter it with stackconf. So now currently I have 1,500 messages in the week, 600 in 3 days, and 200 from the last 1 day. And when I'm going to, let's see this one, I can see the station overview. Nothing producing now. This one is produced in cycles of 1 hour, and this one runs every 1 day. And I can see the messages inside. And now I'm going to try to show you how I collect it, and praying that Elon Musk won't stop me from getting to the limit. So this is the collector, and I'm running the collector. Okay, so I'm collecting tweets and producing them, and it's supposed to show, here you can see that I have new messages entering to my station. Okay, so I finished the collect from the 10 accounts, and now I will try to run the analytics. Well, it took me some time before, so I hope it will be okay now. Okay, so now it begins to consume, consuming messages. And I can see that the consumer you will see in a second that it's connected. Okay. It's now, you can see all the steps. Pre-processing, run the LDA model. Okay, consuming. I made it with batches of 100, so it will take a few seconds. I think this is the last one. No. Okay. So I guess I have already new messages in my BigQuery. I will run this one. And you can see it from now. This is the way that topics looked after topic modeling. For even there I don't know, goals England, Scotland. There was a game yesterday, maybe. Okay, so now after I have this one, I can refresh my dashboard tableau. Let's see. No, it's not refreshed yet. Well, not every demo can be perfect. So, okay, so this is from our last run. So I can see the words here. And if I put it inside some language model, I will be able to make it more readable and try to understand what's going inside the data that I collected. So I think I left some time for questions.
Thank you very much. Really interesting talk. I hope to see, like yesterday was Germany playing.
Yes, I will check if it appears.
I saw some keywords of Germany and football. That's pretty intense, cool stuff. Are any questions from the audience?
Pretty simple question, but so the little Python snippets that we showed, are they running then on the Memphis platform, or are they sort of running separately?
What, the models?
Yeah.
So no, the Memphis is only a place to store the data in order not to use database or something, and then I don't need this data after I analyze it. So this is why I use Memphis, because it's easy. It acts like a buffer, and we have this cloud, so I store it inside. And each model runs in a different. I run it. Now I run it in my computer, but we have a pod that runs every hour the collector, and every 12 hours the analyzer part.
Thank you.
Oh, good.
Just a quick question on the installation. How long does it really take to install, set up, configure, so that we have all the right data flowing in?
Of the entire pipeline?
Yeah.
Well, I made you surprised, and I'm going to upload the entire thing to our repo, so you can just clone it and put your credentials and replace the accounts and just play with it. The setup is very easy. The only thing we have to set up here is just the pods that run every time for the models. And Memphis, just you can start with a simple account, or install it by yourself and play with it on Docker or Kubernetes.
Cool. Thank you. We'll try it.
So, any questions? Otherwise, Sveta will be around at the conference and is open for questions anytime. So, thank you very much again.
Thank you.
And yeah, see you next time.
Thank you.